You know, for years, we've seen AI get incredibly good at tasks based on pure logic. But when it comes to real open-ended creativity, that's always been the big hurdle. I mean, how do you teach a machine to reason like an artist or a writer? Well, today we're diving into a really fascinating paper that flips the script on that whole problem. It proposes a pretty radical solution. What if, instead of teaching AI to think forwards from a prompt to an answer, we taught it to think backwards?
So, here's the plan. First, we'll look at where AI reasoning is at right now. Then, we'll dig into why creativity is such a tough nut to crack. After that, we'll introduce this wild new idea of reverse engineered reasoning, or REER. We'll peek under the hood at its search algorithm, see how a model called DeepWriter performed, and then wrap up with what this all means for the future of AI.
Okay, let's kick things off with Section 1, the deep reasoning frontier. To really get why this new research is such a big deal, we have to first understand what AI is already really good at. So this idea of deep reasoning, where an AI doesn't just spit out an answer, but actually thinks about it step by step, has been a total game changer. For things like math problems or writing code, it's been incredible. Why? Because in those worlds, there's a clear right or wrong answer. The AI has a target, and it knows exactly when it's hit the bullseye. But, and this is a big but, that very same strength becomes a massive weakness the second you step out of that black and white world and into the messy, subjective gray area of creativity. And that gets us to the heart of the matter. How on earth do you apply deep reasoning to something like writing a story? There's no single correct story. Quality isn't about getting the math right. It's about things like originality, or how it makes you feel, or if the plot holds together. There's just no single ground truth. And this is where our usual tools just fall apart. The two big methods we have are reinforcement learning and instruction distillation. For reinforcement learning, or RL, you need to give the AI a reward, a score. But how you give a numerical score for emotional resonance? You can't, really. And the other option, instruction distillation, is basically just paying a huge, powerful model to generate tons of examples for a smaller model to copy. Not only is that insanely expensive, but your student can never be better than its teacher. It's a built-in limitation.
So both of these traditional methods are what we call forward approaches. They start with a prompt and try to either imitate their way or just stumble their way through trial and error to a good solution. And in the massive, almost infinite world of creative possibilities, that is just hopelessly inefficient.
So, faced with this dead end, the researchers did something brilliant. They decided to flip the entire problem on its head. This is the big aha moment. Instead of asking, how can I generate a good story? They started asking a totally different question. Okay, here is an already existing fantastic story. What's the most plausible thought process someone could have followed to write it? It's a complete paradigm shift. So forget that forward-moving process. This new idea starts with the finished product, a really high-quality piece of writing, and then computationally works backward to discover the hidden step-by-step thinking that created it. It's like finding a beautiful statue and trying to figure out the exact sequence of chisel strikes the artist used to carve it.
And that, my friends, gives us our official definition, REER, which stands for reverse engineered reasoning. It's a whole new way of thinking. The key word here is discovers. It's not trying to invent a thinking process out of thin air. It's about uncovering the one that's already implicitly there in a great piece of work. Okay, so the big idea is fantastic, but you're probably wondering, how does this actually work? Let's get into the nuts and bolts. Here's the really clever trick. They turned it into a search problem. But how do you know if you found a good thought process? They used a proxy metric called perplexity. The easiest way to think about it is this. A good plan is one that makes the final story seem totally obvious and expected. If the thought process is solid, the final text shouldn't be surprising at all. The lower the surprise, or perplexity, the better the plan. And the search itself is this elegant four-step loop. You start with a rough initial plan. Then you start expanding and refining bits and pieces of that plan. You evaluate each new refinement using that perplexity score to see if it's better. And you just keep doing that until the plan is optimal. The best part? It's a gradient-free search, which means it's way easier to scale up. This diagram really helps make that loop concrete. You see, you start with a whole thought process. The algorithm then zooms in on one little piece of it, let's say step Z2, and generates a bunch of possible improvements for just that one step.
It checks each one to see which one makes the final answer least surprising, which one has the lowest perplexity. It picks the winner, Z2 star, locks it in, and moves on to refine the next segment. It's this beautiful, iterative process of going from a rough draft to a final, polished plan.
Okay, so the theory is just brilliant. It's elegant, it makes sense, but the billion-dollar question is, does it actually work? Let's check out the proof.
So what the researchers did was they took this REER method and put it to work on a massive scale. They created a brand new dataset they called Deep Writing 20K, which contains 20,000 examples of high-quality writing where they've reverse-engineered the entire thought process. And if you look at what's in this dataset, you see why it's so powerful. It's incredibly diverse, but look at that huge slice of the pie. Almost half of the entire dataset is dedicated to artistic writing. We're talking stories, essays, scripts, exactly the kind of stuff that's been so hard to teach AI before. This is the training data we've been missing.
All right, now for the result that'll blow your mind. They trained a model called Deep Writer on this new dataset. It's only an 8 billion parameter model. Pretty small by today's standards. They tested it on long bench write, a benchmark for writing really long, coherent documents, and this little 8B model didn't just compete, it actually scored higher than giants like GPT-4o and Claude 3.5. That is absolutely stunning. It's a testament to the power of training on high-quality reasoning, not just high-quality answers. And this wasn't some weird one-off result. If you look at the writing bench scores for professional writing tasks, it's the same story. Deep Writer 8B completely crushes Claude 3.5, and it's right on the heels of the much, much bigger GPT-4o. This is definitive proof of the idea. The quality of the thinking in your training data can be even more important than just making your model bigger.
Okay, so let's zoom out for a minute and think about what this all really means for the bigger picture.
When you boil it down, this paper gave us 3 huge things. First, it gave us REER, a genuinely new paradigm for teaching AI how to reason. Second, it gave the research community the Deep Writing 20K dataset, which is going to fuel a ton of new work. And third, it proved you can get state-of-the-art creative results without having to rely on super expensive distillation or complicated reinforcement learning. And what that all adds up to is basically a new third path. It's a scalable, cost-effective way to build deep reasoning into AI models. This is huge because it could democratize this technology, allowing smaller labs and companies to train models with capabilities that, until now, were pretty much locked away inside a handful of tech giants. It really levels the playing field. So I'll just leave you with this final thought. This research wasn't really just about making AI a better storyteller. It was about teaching it to understand the hidden process of our own creativity. And if we can successfully reverse engineer the how behind our most complex, subjective, and human thoughts, what's the limit? What can't it learn?